Welcome on Cool Paradigms. Here we are concerned with passive cooling, testing it on the Raspberry Pi 5 using EDA tech case. So, after a few tests, the most efficient position for that case was the vertical one, which is made possible here with this actual foot. So, why is the vertical position more efficient? Because the inside of the Raspberry Pi, the heat can just go straight through. The horizontal position would be good because we have a sort of hot air bubble just below. And when it's vertical, the airflow can just glide easily on each side. So on the top of the of the air that can go through the middle part. So here we are. Enough for now with this gimmick. So here we have this model here, which is supporting Raspberry Pi with an aluminum foot, having the task to make it vertical at a good distance from the table, and also to cool it down with an efficient aluminum large part, which is going quickly far apart from the main body to get some fresh air outside. For the front, we have two parts. This huge nose here, looks like a bird, with a direct connection on the main case, and a hat part. By the way, this one is better horizontally because we are able to drill holes, so it can just suck up more fresh air with a larger surface, larger array. Of course, it's not possible here because we can't drill hole through the whole things and through the computer card. So we obtain about 3 less centigrade degrees with that part, and the same with that part, top hat, which is mainly, the main idea was a protection, a top protection, so the Raspberry pins would be protected from small falling objects and inadvertent finger touching. So, it could be possible to doubt from the efficiency of the things because the top part here is just on the main warm airflow from the main Raspberry body and somehow a bit of the back passive cooler. So, how come it's efficient? Because it's mainly made of two parts. It's almost divided by a huge line of holes, which allow to not have too much heat conductivity because we don't have much aluminum array linking the bottoms of and the top part of the hat. So we save although about 3 degrees. Same sort of rentability from the two parts. So it's a good idea to have a look at the graphics for the different temperature measurement, and that's this funny looking model which got the best results, going to 59 centigrade degrees when obtaining stabilization with the 4 processor running at 100%. So it's a maximum, of course, a maximum load for the processors, but not for the memory and so on. But it wasn't my main concern because with 8 gigs of memory, it's already very good, and I was not too concerned with other part. I'm not using the Wi-Fi and so on. By the way, this part is a bit long, so it's efficient, but I think we wouldn't lose too much in efficiency if it was maybe going to lose 1/3 of the length here, and it would be more practical to manipulate, because even there I have to be careful not to bump into the camera. Before miling or filing, the thermic gel must be removed carefully from the passive cooler, and once the metal work is done and the cooler clean, put back in place with the same care. On the fabrication side, the original passive cooler was milled to obtain a better thermical contact. By the way, it's also possible to file it, but it would be across the whole width of the passive cooler. Then a bit of drilling and threading the holes for good connections on both sides of the original passive cooler. Thank you for watching.